Assalamualaikum warahmatullahi wabarakatuh. I'm here to discuss about how to find instantaneous reaction rate through this reaction. And first, this harder question. A student investigated the kinetics of this reaction and obtained the following data. So I have already plotted the data here using GeoGebra, which actually you can also do this instead of using micrometer block. And then here are the plot. And the next question is determine the average reaction rate with respect to iodine in mole per decimeter cubic per second or in molarity per second during the first 30 seconds of the experiment. So basically, the only formula we're going to use to answer all these questions is only this one, which is velocity or rate equals to an absolute subtraction between the after and before of the concentration per the subtraction of the time. Or in here we call it delta concentration per delta time. Now, first one is this one. This is for 30 seconds. So here is 30 seconds. And the velocity will be the after, which is this one, of the concentration. The concentration is 1.55, so I put it here, 1.55 minus 0 because it begins in 0. And then per 30 seconds minus 0. So the answer would be 0.05166 and so on. So we're going to round it into 0.052 molarity per second. Or you can also make it into 5.2 times 10 minus 2 molarity per second. So this is the average velocity or the average rate of concentration from 0 to 30. Now, to find the initial and the instantaneous, it's like this or the average of 0 to 30, the average of here. Because usually when you find the average of something, the graph should be a straight slope like this. However, since a reaction is not going to work as it's a steady pace of velocity, it's going to be a curve. So in the initial and instantaneous, is the question is asking in that specific moment what is the velocity of that specific moment. To know that, we need to create a slope, but then we don't have to make a full slope. So what I mean by slope is like this. If you have a graph and then straight like this, so every single dots in here will have the same velocity, or in this case will have the same rate. However, since we are having this type of graph, it will have different velocity in different moments. So in order to find the specific rate of certain dots, you need to create yourself a slope, which is, we call it a tangent line. So here is the initial, which is 0. So this is my tangent line. I just put it everywhere you like because the result will be the same. And then this is the instantaneous on the 30 second, which is here. So we're going to calculate the initial first. Again, it's the same, after minus before. So the after here is 0.3 minus 0 per 1. This one will goes here as in 1 minus 0. So the initial rate will be 0.3 molarity per second. Now, how about the instantaneous? I use this one. Then you need to create 2 dots. So this is the 30 second, and then this is my tangent. Okay, if I can zoom it a bit, and there you go. here is the line. I will have to move this for a while. Okay, you can see the line there. So there are two dots, which is 25.28 and 1.47 and 34.4 and 1.63. Now here we are going to write down the instantaneous rate. Let's start with after minus before. The after is 1.63 minus 1.47 per 34.4 minus 25 point. We're going to round this into 3. Round up into 3.3. So the answer would be 0.017 meter per second. So this is the instantaneous rate within 30 seconds. Now we move on to the next calculation, which is calculate the overall initial reaction rate. So to do that, you need to pay attention at the reaction here. So I've already write down the reaction here, and the iodine will be in 3. So whatever this is you get from here, it's going to be divided by 3. Okay, the question is the overall initial rate. So going to scratch this one. It seems that we have different questions to the sample that I gave you before. The question will be overall velocity for initial rate, or for our initial rate. So you're going to use this one because the question is the initial. So the V initial for overall is going to be 0.3 per 3. Why 3? Because we are talking about iodine here. So look at the coefficients of the iodine. Then you put it here. So the overall initial rate will be 0.1 molarity per second. What happens if the question is the overall velocity for instantaneous within 30 seconds? It's going to be this one divided by 3, 0.07 per 3. So the answer would be 0.017 divided by 3 is 5.7 times minus 3 molarity per second. So there you have it. This is like what is the rate when it's going to start is 0.1 molarity per second in overall. If we call it overall, it's going to be 0.1, but if it's in that specific moment, it's going to be 0.3 molarity per second. So for the instantaneous reaction rate in 30 seconds, it's going to be 0.017 molarity per second. But if we calculate it as an overall, it's going to be 5.7 times 10 minus 3. Or 0.00057. So I hope you can calculate the instantaneous and the initial rate by using this video. Wassalamualaikum warahmatullahi wabarakatuh.